How's it going, ladies and gentlemen? Mr. Donahue here once again. This time we're going to take a look at 2.1 and 2 problems, the history of the atom. So number 1, a molecule of water contains hydrogen and oxygen in a 1:8 ratio by mass. This is a statement of what law? This is the law of constant composition. So a given chemical compound always contains its component elements in a fixed ratio by mass and does not depend on its source and method of preparation. So if I get water from the tap, I fill up a glass of water, it's going to be H2O. If I fill up, I take an iceberg and I melt it, the water's still H2O. It doesn't matter where the water came from. If it's water, that's what its composition is going to be. It's going to be constant. Number 2, consider the following selected postulates of Dalton's atomic theory. So we have 4 of them there, and which of these postulates is or are no longer considered accurate and explained. So let's take a look at the first one. It says atoms of different elements are different and have different properties. That is still a true statement, so I'll say true. Atoms are indivisible. This one is not true anymore. It's false. Because why? Well, we know atoms are made of protons, they're made of neutrons, they're made of electrons, so it can be broken up into those things, so they're no longer indivisible. Atoms of a given element are identical. That one is also false because we have isotopes, right? We have atoms of the same element with different mass because they have a different number of neutrons, so they're not identical. Each element is composed of extremely small particles called atoms. Well, that's true, right? So which ones are false? Postulate 2 and 3. The charge of an electron was determined in the blank. So here's your options. The correct answer is the Millikan oil drop experiment. So basically it was oil drops shot with X-rays so that they'd become charged particles. And then you can see how they respond to an electric field based on their charge, and that's how they ultimately figured out the electron was. You can Google that or search that and find a better detailed explanation. This is just kind of testing that you know that the name of that experiment. 4, a certain mass of carbon reacts with 25.3 grams of oxygen to form carbon monoxide. How many grams of oxygen would react with that same mass of carbon to form carbon dioxide? So this problem has to do with the law of multiple proportions. So it's saying for every some amount of carbon, it would react with 25.3 grams of oxygen to give me CO, or carbon monoxide. So it's saying, all right, if I use the same amount of carbon, how much oxygen would I need to react with to give me CO2, carbon dioxide? Well, if I needed 25.3 grams to give me CO, I need twice that to give me CO2. So just double it. It would be 50.6 grams of oxygen needed. Which statement below correctly describes how alpha, beta, and gamma radiation responds to an electric field? So I'm going to draw an electric field. I have a positive charge here and I have a negative charge there. So how is the radioactive particles going to react? How are? Well, let's say I have a stream of them going this way. Well, I know if I have a negative particle, it's going to be attracted to the positive pole. And what negative particle do I have? The beta. If I was positively charged, I'd be attracted to the negative pole, and that is going to be the alpha particle. And if I had no charge, the electric field's not going to affect me at all. That's going to be the gamma. So which option looks like that? Alpha and gamma are deflected in the same direction? Nope. Alpha is deflected, beta and gamma show no response. That's not true. Beta and gamma are deflected in the same direction. Not true. Alpha and beta are deflected in the same direction. That is not true. Alpha and beta are deflected in opposite directions and gamma shows no response. Choice E. 6. What did Rutherford's gold foil experiment establish? All right. So here are your options. It led to the discovery of the atomic nucleus. Well, that's a true statement. That's how we discovered the atomic nucleus. Well, let's check the rest of them, though. It utilized the deflection of beta particles by gold foil. Trying to get you there. It wasn't beta particles they were using. They were using alpha particles. So definitely not choice B. That's false. It was the basis for Thomson's model of the atom. That is false as well, right? Rutherford was testing Thomson's model. It proved the law of multiple proportions. Nope. It confirmed the plum pudding model of the atom. In fact, it did the opposite of that. So, correct answer, choice A. And yeah, I think that's all the practice problems. Hope you found it helpful. See you in class. Okay, bye.